All right, talking about functions, domain, and range, words that are associated with domain. Domain's always going to be your x values. Another word you might hear is input. For your range, it's always associated with your y values or output. So you have a domain of a function and range of a function. Let's look at this first example here. If I want to find the domain, we're just talking about x values. So I'm just looking at values on the x-axis. So basically notice that I don't have any x values over here, right? It starts where that line is, and that line is -1. That's the x value. So I know that my x value starts at -1, and it just continues going on and on to the right. Right, this arrow indicates that it'll continue going on and on and on and on. Okay, so how do I write that mathematically? Well, you can write it like this. X is greater than or equal to -1. The reason you say it's greater than or equal to is equal to because this dot is closed, right? It's filled in, it's solid. Okay. It's greater than -1. That means it's, of course, it's going to the right, and -1 because that's where it starts. Now, the way you might see this the way that you need to know how to write this is curly brackets, x, a set of x, such that x is greater than or equal to -1, and curly brackets. You need to write it that way. Range. Range is just talking about your y values. So I'll go ahead and erase this. Your y values. That means you're just looking at values on this y-axis. Here, y is -3. You can see that it doesn't go past this point. It goes up, right? Up and to the right. So that means y, or our range, will be always greater or equal to -3. The way we write that, curly brackets, the set of y values such that y is greater than or equal to -3. Let's move on to example 5. Example 5 is asking us to find, for each of the graphs, state the domain and range. And now we're looking at a graph, similar. They're telling us that's the point 4, 3. They're telling us this is the point 8, -2. Notice that this point right here stops. This part right here keeps going on and on forever and ever. That'll affect both our domain and range. So our domain, we'll make this red. Only looking at the x-axis here, okay? So how far to the left and to the right does this graph go? Well, this arrow right here tells me that it keeps going up and up and up to the left. That means it goes on and on and on to the left forever and ever. However, this dot right here tells me that it stops at that x value. That x value is 8. So my domain is curly brackets, the set of all x values such that x, now x has to be less than, because it's everything to the left of, less than or equal to, it's equal to because it's including 8, and that is 8. Done. Now we'll move to my range. My range, I'm just talking about my y-axis. I'm just going to be looking at my y values. Notice that, again, this part here, it stops here, and this keeps going on forever and ever. So I'm curious about my y values. So it starts at -2, and it continues to go up and up and up. So my range values would be y, sorry, the bracket means the set of all y's, colon means such that y is greater than or equal to -2. There are your answers. This next one you can try on your own. One word here, if you see x is an element of this, what does that mean? All that is saying is that on a number line, that x can be any one of these numbers on the number line. So instead of saying x can be anything, you just write x is an element of all the real numbers. They can be any real number. Okay, that means there's no restrictions at all. Let's look at example number 6. Example number 6, state the domain and range of each of the following functions. Okay, so this we don't have a graph, and let's say that we don't have a graphing calculator. How can I know what my domain is? Well, remember, your domain is x values, right? So, for instance, x minus 5. This function is unique. Let me erase this. Because if I were to set it, well, the square root function is unique because nothing under here can be negative. So the only input values that we can put in there are values that would have to make this 0 greater than or equal to 0. So if I just solve this, x is greater than or equal to, I add 5 to both sides, 5. That tells me that every value 5 and above would make this some positive number. You can do that, right? But if x, let's say, for instance, was was 4, well, that would be 4 minus 5, which is a -1. And right now, we cannot take the square root of a negative number. So our domain here is all the values of x such that x has to be 5 or greater than 5. So basically you're asking yourself, where is the function undefined? Okay, that's the domain. We're doing just A here. All right, let's look at B, or let's look at range, the range. All right, so if we can only use x greater than 5, well, plug 5 into f of x, and we can find what our range is going to be. So f of 5 equals square root of 5 minus 5, which is 0. So f of 5 equals 0. Now, what does that tell me? That tells me, well, let me just plug in 6. What if I plug in 6? Well, 6 minus 5 is going to give me 1. If I plugged in f of 7, 7 minus 5 is going to give me square root of 2. You can see that's going to increase 5, 6, 7. That means that 0 is going to be our lowest number, and from 0, we're going to go up. So my range would be the set of all y values such that my lowest y value is going to be 0. So y is going to be 0 or greater, because it's going to increase each time. So let me write my final answer up here. Y such that y is greater than or equal to 0. Again, you're answering the question, where is this function undefined? In B, you can see that this is in the denominator, and the denominator can't be 0. That's key. Same thing with this one right here. The point is, you're supposed to do this without graphing. That's it for domain and range. Just as a review, domain is your X or your input, range is your Y or output. This is the format you need to be able to write it in. You'll be asked graphically to find the domain and range, and algebraically, where is the function undefined, domain and range.